Imagine an aircraft engine with a fan diameter larger than the fuselage of a Boeing 737. This is precisely what General Electric achieved with the GE9X, an engine poised to power Boeing's upcoming 777X aircraft. It's not just its size that's impressive. The GE9X promises to bring revolutionary changes to the aviation industry. However, to fully understand its significance, we need to explore the history that led to its development. The origins of the GE9X date back to 1990, when General Electric partnered with SNMA and Avio to create the GE90 engine. This engine was a breakthrough for General Electric, as it was their first to exceed 100,000 pounds of thrust. Designed for Boeing's 777, the GE90 featured innovations like 22 carbon fiber composite fan blades, which offered double the strength but only 33% of the weight of traditional titanium blades. The GE90 set the stage for what would eventually become the GE9X. In 1999, GE secured an exclusive deal with Boeing, ensuring that their engines would power future 777 models. This deal locked out competitors and gave General Electric the green light to begin work on the next evolution of the GE90, the GE9X. The exclusive agreement between General Electric and Boeing in 1999 was a strategic win for General Electric. With its rivals excluded, General Electric became the sole provider of engines for the Boeing 777, which allowed the company to dominate this segment of the wide-body aircraft market. The GE90 became the engine of choice for airlines operating Boeing 777s, and the relationship between Boeing and General Electric only grew stronger as plans for the 777X emerged. By locking out other engine manufacturers, General Electric was able to focus on refining its technology to create the GE9X, a more powerful, more efficient version of the GE90 designed specifically for the next generation of aircraft. The GE9X stands as the largest commercial engine ever built, with an impressive 133.5-inch fan diameter. This isn't just about size, though. Engineered specifically for Boeing's 777X, its high-bypass turbofan structure increases fuel efficiency by moving more air at lower speeds. Using advanced materials and technology, General Electric has crafted an engine that's both powerful and lightweight, promising to redefine long-haul aviation. During development, the fan diameter grew from 128 to 133.5 inches to improve airflow and efficiency, while the engine's thrust was raised from 99,500 to 105,000 pounds to meet Boeing's needs. These refinements ensure the GE9X is optimized for the 777-8 and 777-9 models, balancing power with fuel efficiency for extended flights. Fuel efficiency is a critical concern for airlines today, and the GE9X delivers impressive improvements in this area. It is 10% more fuel efficient than its predecessor, the GE90, which is a significant leap forward for long-haul flights. The GE9X achieves this efficiency with its overall pressure ratio of 61, which allows it to produce more power with less fuel. Compared to its closest rival, Rolls-Royce's Trent XWB-97, the GE9X offers 5% lower thrust-specific fuel consumption. This translates to significant fuel savings over time, helping airlines reduce costs and their carbon footprint. The engine's efficiency is one of the reasons why it has attracted so much attention from airlines planning to operate the Boeing 777X. One of the major innovations in the GE9X is the reduction in the number of fan blades. Unlike the GE90, which has 22 blades, the GE9X uses just 16 blades. This reduction in blade count decreases the overall weight of the engine and improves its aerodynamic performance, allowing the fan to spin more efficiently. The fan blades are made from advanced composite materials that enable them to handle greater stress while reducing drag. The GE9X also features a high-pressure compressor with a 27:1 pressure ratio, one of the most efficient compressors ever used in a commercial engine. This compressor, with 11 stages of compression, helps the GE9X deliver more thrust while maintaining lower fuel consumption, an important factor for airlines operating long-haul routes. The GE9X stands out for its use of ceramic matrix composites, CMCs, which are lighter and stronger than traditional metals. These materials are particularly useful in the high-temperature regions of the engine, such as the combustion chamber. where they help the engine operate at higher temperatures without risking structural failure. CMCs are not only twice as strong as metal, but also 33% lighter, which contributes to the overall weight reduction of the GE9X. In addition to improving performance, CMCs also make the engine more sustainable, as they help reduce fuel consumption and extend the engine's operational lifespan. This use of advanced materials is a key factor in making the GE9X one of the most efficient and durable engines in commercial aviation. Reducing emissions is a top priority for airlines, and the GE9X is designed with environmental sustainability in mind. The engine features the TAPS, Twin Annular Premixing Swirler, combustion system, which reduces emissions of carbon dioxide and nitrogen oxide by premixing air and fuel before combustion. This technology results in cleaner, more efficient fuel burn, cutting emissions by 55% compared to other engines in the same class. The GE9X not only meets but exceeds the latest regulatory standards for emissions, making it one of the most environmentally friendly engines available. For airlines, this means they can meet strict emissions requirements while still operating a high-performance engine. The GE9X has garnered significant interest from airlines around the world. Emirates was one of the first to place a large order, signing a $16 billion, 12-year maintenance and overhaul deal with GE Aviation in 2015. By 2022, Emirates had ordered 460 GE9X engines and spares, making it one of the largest operators of the engine. Other major airlines, including Lufthansa, All Nippon Airways, Singapore Airlines, and Ethiopian Airlines, have also placed significant orders for the GE9X. These orders reflect the growing confidence airlines have in the GE9X's ability to deliver on its promises of fuel efficiency, power, and low emissions. Despite its many strengths, the GE9X faced some challenges during development. In 2018, the engine's first test flight was delayed due to issues with the high-pressure compressor's variable stator vanes, which caused exhaust gas temperatures to rise beyond acceptable levels. This resulted in premature wear on some components, requiring further adjustments before testing could resume. GE successfully addressed the issue, and the GE9X completed its first test flight in March of that year. However, in 2022, Boeing had to temporarily halt the 777X flight test program after detecting another temperature-related issue with the GE9X. These setbacks were frustrating, but GE has remained confident that the engine will meet its performance targets and enter service on time. As we look to the future, the GE9X is set to power Boeing's 777X into commercial service by 2025. The first production engine has already been delivered to Boeing, marking a significant milestone in the project. With its unmatched combination of size, efficiency, power, and sustainability, the GE9X is expected to lead the way in the next generation of commercial aviation. Airlines are increasingly focused on reducing fuel consumption and emissions, and the GE9X offers a solution that balances these priorities with the need for performance. While the engine's journey hasn't been without challenges, it's clear that the GE9X is poised to make a major impact on the aviation industry.